All right. All right, perfect. So we're live. Hello and welcome, everybody. My name is Marcin, and today's topic is actually about a useful internal framework. I just had an amazing opportunity to work for a company that I really loved the internal framework there, and I really just wanted to share. So let's dive in. Let's talk about it a little bit. But first, let me just clarify one small thing because I wanted to underline that beforehand. So when I'm talking about the internal framework, I'm talking not only about the code, not only about a NuGet package or the packages like a collection of them, right? I'm talking actually a little bit further. So I'm talking about what do we do in general. So how do we approach code writing? How do we approach the what do we really use, right? So what kind of architecture, what kind of structure, what is going on? So this is this is a presentation about the framework, but it's actually a little bit wider, so just wanted to preface that. All right. So, what company are we talking about? The company we're talking about is actually called Demand. And at least for me, when I heard that name for the first time, I actually had pretty much no clue what Demand does. So, let me guide you a little bit because what they do is actually, well, hearing aid devices. And I personally don't really have anybody that is hearing impaired within my closest circle, right? So I don't really know the state of the art currently. So I'm happy to report after working for Demand for a bit that those hearing devices are actually getting a lot smaller and much more, well, compact, easy to hide, and so on. So they actually look pretty much like this. This is the standard unit. There's actually even smaller ones, like much smaller, that fit completely into your ear canal. So that's a possibility. But in general, for the general public, the hearing aid looks a bit like this. So as you can see, it's a small unit. You can pretty much hide it behind your ear, and there's this small little tube or the wire that goes into your ear canal. And this is actually everything you need. So yeah, I'm glad to report this is the state of the art currently. However, I joined the company and I learned pretty quickly that the project I will be working on is actually not touching this whole domain. It's actually even a different company or a sub company of Demand, which is called EPOS. And then again, I had to go with, like, what the hell does EPOS do? So the answer is actually they do a lot of headsets. So they target two main demographics with their products. They target the gaming demographic, but also like the enterprise, the companies. So any sort of those headsets that you would see in a call center, they also have those sort of things, right? And the headset you can see right now on the screen is called EPOS H6 Pro Open headset. Open because it's an open back headphone, and it's actually very well received within audio community. I was actually kind of surprised because I love headphones. I really do. And you can see like the mic I'm using is sort of unorthodox to say the least, just because I love this topic and I really enjoy everything that is connected to audio. All right. So what's really cool about this headset is it's actually apparently it's super comfortable. You can wear it all day long without any sort of issues. And the flip up mic is also very praised because you can just flip it up to mute it. Very convenient, easy to use, and so on and so on. And they swivel quite a bit, so they really match the shape of your head easily. So that's awesome, right? And the company I also mentioned, they do work for the enterprise, right? So anything that is related to the meeting rooms also, that's also something that they do. So actually cameras, microphones, those loudspeakers and so on, all of this EPOS is sort of connected to, right? And one of those devices that caught my eye is actually this. And this thing is called EPOS GSX 1000. It's an audio interface or an external audio card. And you probably can see from some of those icons like 7.1 that this product is actually targeted towards, once again, gaming community. And because 7.1 is actually useless when you watch movies, more or less, right? It's sort of the marketing gimmick for FPS games, because you actually can hear directionality of your opponent's footsteps and so on. So this is actually useful there, right? It's not for, as I mentioned, movies or music. It's not really that good, not so great, especially since we record music rather differently. We rather target the stereo and so on. But it caught my eye because of a different thing. It caught my eye because I remember this device. And this device is Sennheiser GSX 1000. So my first question was pretty much for the entire EPOS. Like, what the hell, guys? Did you freaking rip off Sennheiser? Did you just like change some colors, put your name on it, and like, what the hell? What's happening here, right? And it turns out actually that Demand and Sennheiser are cooperating quite heavily through the past few years. So Sennheiser is really famous for their headphones, right? They're really famous in the audio space, which I'm part of, and I definitely have too many headphones that I could count. But yeah, so in 2003, actually, EPOS wanted to, well, um, they wanted Sennheiser to produce some headphones for EPOS, or rather for Demand at that point. They really wanted to slap their name on the headphone and sell it themselves. And since they didn't have the know-how, they wanted to cooperate with Sennheiser. They wanted Sennheiser to be the OEM, right? But apparently, Sennheiser's owner and Demand owner really hit it off. They started talking. They wanted to do really similar things with the enterprise and gaming, and they decided to actually to create a joint venture. So they created a one company together, which was called Sennheiser Communication. Well, they wanted to utilize obviously the Sennheiser brand, Sennheiser name. They wanted to use that, so that's where Sennheiser Communication was born. And 15 years later, actually, the joint venture did so well that they wanted actually to separate. They didn't want to, like, the company grew so big that it actually didn't make sense for the two companies to like lead it together. They actually wanted to create a completely separate third company. And that third company is called EPOS. That's why some of the devices, like you can see right now on the screen, were sort of transferred to the EPOS name, right? And 2018, they decided that EPOS uh, should be, and 2 years later, actually, Sennheiser Communication ceased to exist. So now there's three companies. There's the Sennheiser, I think it's called Sennheiser Consumer now. There's Demand, and there's EPOS as a third one. All right, so at least that cleared things up. All right, why am I talking about this? So this is this is not coding, right? But I hope you can see that I'm very passionate about the topic just because I just love it, right? It's simple as that. So the question really is, when I joined EPOS, what did I actually do within EPOS? And what did I do was integrations within e-commerce solution. What do I mean? If on the left we've got the warehouse, on the right we've got the website, and customers can go to the website to order something, so the warehouse has to process it, and so on and so on. So right there in the middle was actually my team. So what we did was just translations of APIs so they can actually match, because those two separate systems didn't really talk to each other. So we had to do that translation and that integration between them, right? So yeah, if you think this is boring, you're absolutely 100% correct. This is the very definition of the word boring. This is like nothing at all happened. We just took one contract, took the other, and just meshed it up as much so they actually fit, right? So yeah, this is the very definition of the BLOBA term. And if you're unfamiliar, BLOBA means boring line of business application. And yeah, we programmers, we love to work on interesting domains. But well, the reality of it is actually the boring thing is important, because as you can imagine, getting that order from the website to the warehouse is very important for the business. This is what brings money, right? So boring, as in nothing interesting is happening underneath. This is very simplistic and sort of a given, but it works and it needs to work because it's important for the business. So yeah, boring sometimes is good, especially since we're engineers. That actually may be very, very good. The term itself, I actually heard for the first time from Uncle Bob, Robert Martin, and love or hate the guy, the term BLOBA is absolutely perfect. And from today onward, you can use it freely because it's just too damn good. All right, let's move on. And let's consider the domain and the usage of the application. Let's stop for a second and let's think about what we really need to do, what we want to achieve here, right? So the first thing I already mentioned, there are two APIs and we need to match them together. So this is called data shape transformations, right? That's a given. We need to do that. No discussion here. The other thing is we sometimes will have the need to react on an event in multiple systems. So a excuse me. Simple example once again is there is the order from the website and we need to communicate that to the warehouse, to the shipping department so they actually ship the product, but we also need to get the invoice to the customer, which is like a different department or a different system. So from time to time, we will need to react in multiple systems for one single event. Then, since we have that reply from different actual systems, it really doesn't need to be so synchronous, which is super beneficial for us because we can lean in on the eventual consistency more, right? So the synchronous response is not that important because if the message that we receive is complete and we understand it fully, it's our job then to give or to let those systems know, right? So it's completely 100% on us at that point. However, since we don't care about synchronous response that much, the monitoring of the solution becomes much bigger of an issue, or at least much bigger of a concern, right? So keep that in mind. Okay, so the story continues. I joined EPOS and I started as usual with onboarding. And in onboarding, I actually met Frederick, really awesome guy. He's like an architect of multiple projects there, right? And he explained to me Well, first of all, the business itself, which I already covered a few slides back. He also explained that they have the API first approach and the framework. There's actually like two things, and he mentioned both of them at the same time. So, what does API first stand for? Well, we're focused on bringing the connectors, so the separation of concerns. So we have connectors to each of the systems which understand that system particular data, right? We have the integration API, or the common part in the middle, with domain model, with our domain model, right? And then we have the communication between them that just flows through the integration API, since we have that common understanding there. But he also mentioned that we have the framework itself, which covers some of the base functionality of the framework. It covers also the domain specific functionality, or how the code is organized, and so on. So we'll take a look at that step by step. So first, we're covering the basis. We're covering the most important questions of the project itself, because there's actually multiple projects that use this sort of approach. Okay, so what you'll see now is actually there will be two columns, right? So on the left side, there will be like a concern that we need to talk about, and on the right side, how do we approach it? How do we deal with it? Okay, let's jump in. So first thing is availability of the solution and load balancing and so on. And since we lean heavily on Azure, there's actually an easy answer for that, which is serverless, which is the Azure Functions, right? You pretty much get the load balancing completely for free. You don't really care about availability. It's a simple thing, right? It's standard at this point, pretty much. All right, we also need some different environments, as pretty much each and every project in in the entire universe. So we'll then lean on the .NET itself with app settings JSON, which you can easily configure for dev environment, for prod environment, for UAT environment. It's quite easy, quite handy, right? And that app settings translates 100% into Azure function configuration, which is lovely. And as .NET developers, we sometimes don't really appreciate how seamless this actually is. Next, we needed some cheap storage. Since I already mentioned we're actually communicating between multiple systems, those systems have databases. And our job is not to store the data. Our job is to know where that data should come from and so on, right? So we don't need the database. However, we do need some cheap storage so we can monitor the solution, and we can do it easily. And that's easy. Once again, Azure Storage Account or the blob storage and so on. Just use it. It's perfect. Then we need, since we're using storage, since we're using files, we need some input and output resilience, and that can be done once again really simply with base repository class. That includes some retries and so on, retry policies and so on, right? The same thing with HTTP resilience. You've got Poly, which is absolutely perfect. And actually, in EPOS, we use something very similar, but internal. But the idea stands, right? You have that based, or rather, that built-in resilience. You don't have to think about it too much. So you don't have to think about what happens if I have very brief outage, internet outage, right? You just do a retry with Poly, and you're golden. You don't have to worry about anything. Next thing, since our messages could be quite big actually, because that might be a lot of data, we had to take care about the message sizes also, okay? And that's once again quite simple. It's a batching service. So what you do is you have 10,000 messages and you divide them into hundreds. or maybe thousands, however you prefer, however big the single message is, right? So the batching service used a service bus and our blobs or blob storage, and it's super simplistic, but it works. It's a tried and already like covered with tests solution. So yeah, it just works. It's beautiful. That's everything you need. That's it. All right. About the architecture concerns, we used pretty much the onion architecture. So we have everything domain centric in the center of the of the architecture, and on the outside we build in those ports and adapters for easy swapping if we need it, right? And the second concern, really connected to the architecture, is maybe we're leaning too much on Azure. As you can see, probably we're doing anything in Azure, right? We have 100% Azure focused solution here. But since we're using that onion architecture, and since we're using ports and adapters, we can easily separate everything related to Azure to one project, and if need be, just separate it out, just exchange it for AWS or something, right? It's always good to have that option. It doesn't have to be like super simple. You don't have to abstract absolutely everything. It's not really worth it usually, but it's really good to have that option. And a simple example is when you have the entry point for the function itself, right? The functions are for that project really, really simplistic. You just put in the service that you want to use and you trigger that service. That's it, right? You don't do any logic in that entry point level because you want to be ready to exchange it if you need to. So it's all enclosed in a separate, well, maybe not solution, but really a separate place. Okay. Next thing, CI/CD, or actually the infrastructure also in here, right? So we use fully Bicep to keep everything in order and to keep that coherent environment, right? We have everything always connected, and it's actually held in the same repo. So if you, I don't know, create a completely new part of the solution, completely new connector, you have to add that into the Bicep because otherwise it will just not work. Simple as that. And after he explained this to me, that was just so refreshing, so awesome. All of those questions, those base questions, are completely covered from the get go, and they are tested, tried, and true, and they're just lovely. So, yeah, huge win and huge relief once again when you join a team that already has everything of those bases covered. So, yay! I love that. Let's continue because now let's dive in similarly to cover the domain, right? So I already mentioned 3 points that we really need to think about in the domain. So once again, similar idea. On the left side, you have the thing we need to cover, and on the right, you have our answer, right? So for the data shape transformations, we had that whole idea of connectors. I mentioned that already, but if we have three systems, A, B, and C, we have also three connectors, connector A, connector B, connector C. And connector C understands the data in the system C, but it will never allow the data to go out of it into our solution, into the integration API. It's not allowed, right? So whatever you do within the integration, you push along in the domain model. You don't use the model of the system. And that's awesome. That's really, really great. It works perfectly fine because you've got separation of concerns actually for free. It's completely awesome. So much recommended. It's an old idea. It's nothing new. It's just so great in its simplicity. That's it. Okay, so the next point was that we need to react on event in multiple systems, and we also don't need to care that hard about the synchronous response. So that together really kind of screams publisher and subscriber mm, design pattern, right? So the idea is you utilize some sort of a queue. It was service bus for us, but you utilize some form of a queue. You push the message to the queue, and then you have multiple subscribers that can react on that message. So yeah, one message, multiple subscribers can react. Really simple idea once again, um, but it works. Okay, monitoring is important. And since that monitoring really was kind of crucial, we had to do something about it. And here it's actually something called check-in service that was utilized, which is a completely separate solution, completely separate service within demand or within EPOS. And to at least give you an idea, um, the main job of that thing, of that check-in service, is to collect simple logs and to be able to group the logs by correlation ID. And the correlation ID well specifies one flow of the message. So if the message comes from system A, lands in our integration API, lands in the queue, and then we have the reaction in system B and system C, that every message along the way actually utilize the same correlation ID. So yeah, and you do that in middleware, so you don't even have to actively think about it. It's just done pretty much automatically. And I learned actually quite soon after this project that the OpenTelemetry has the same idea. It's once again simple. Ideas are great. I love that. I think you caught that already from me talking, really. So the OpenTelemetry's idea is called traces. Very much recommended if you want to use something out of the box. And yeah, we just wanted that check-in service is perfect. But if you think about it for a second, there's not that many HTTP messages coming through the system. Like from time to time, you have to transfer actually the file rather than the HTTP message, or you have to do something else crazy like put the message on the queue. Right? It's not an HTTP message per se. So we wanted to improve the monitoring. We wanted to have more details. So we actually used mediator or the command and handler design pattern. So that helped us out quite a bit because even a file received can be a command, and then the handler can once again utilize the middleware, can utilize the check-in service easily. So yeah, that's the thing. The last concern we had, actually, which I haven't mentioned yet, we realized that those systems that we were talking about, some of them are actually quite old and they don't really deal well with HTTP. So we need to access the files on-prem because some of those systems could utilize only the files as a form of communication. And yeah, that's a it's a story old as pretty much uh, the cloud itself, right? You had to have that access to the files on-prem. And our answer was actually the Azure Data Factory, which is kind of curious. That was my first actual usage of ADF. So let me briefly describe it, because ADF is actually a sort of a low-code solution which gathers the data, translates it, and pushes it forward, right? So if you really try, you could use that solution for the entirety of our project. but we wanted to use it to access the files on-prem. How do you do that? It's actually quite simple, because Azure Data Factory has something that is called the integration runtime, which is just a service that you install on your servers on-prem. It's just an exe file that you install there. It runs as a service, so it runs with the PC itself, and that can communicate quite easily with ADF. That can easily push those messages or the files into ADF, and the ADF then can handle it to push it to blob storage, for example, and to trigger our functions if needs be, right? So you have two things in, like, two birds in one stone, with one stone. Yeah, that's the saying. Because not only do we get the files, but we also automatically can trigger the function itself. So yay. However, there's um, there's something I want to warn you about, because Azure Data Factory is actually like built on each use. So what we did initially was just check out the um, the files on-prem, check out the common folder each minute. So it just triggered each minute, and it checked if there's a new file, copy it over, trigger the function, and so on, right? And since you pay not only for the pipeline, but actually for each action itself, even checking was built separately, then copying was built separately, and so on and so on. So we didn't really care that much about it, because we didn't understand how it works, and we ramped up a $1,500 a month for ADF itself, which is, for such a small solution, it was kind of abysmal. it was really stupid. So I don't recommend that. However, if you do it a little bit smarter, if you figure out which files are actually needed when, and so on and so on. If you do some tinkering, we were able to decrease that 1500 to 100 a month. And actually, that 100 was for the whole solution, not ADF itself. So you really need to take care for it. And there's even better solution, because you can, on those integration runtimes and those on-prem servers, you could do an actual process that will watch the files, and then it will connect to ADF only when it's needed. And that would be actually perfect. So that's a next step in this whole journey. Yeah, definitely. Either way, ADF, very simple. You can keep it in the Git repository. Yeah, just cool. That's it. All right. So the last thing I wanted to talk about is the code structure, and that was actually based on features. Once again, um, this is really awesome. So I would call it a vertical slice light code structure, because the whole idea is you pretty much get your application or your architecture, and you slice it vertically to um, to have everything in one feature, in it. Okay, so the simple example is, we're used to creating a repository for a database, right? And it's a huge repository. It has multiple things and so on, because we're focused on the database as a completely separate unit in our code, right? But if we use this vertical slice light architecture, we use something that is kind of similar to repository shard. So for this feature, we need only this part of the repository, and this will live in this one folder, which is called transfer order, because that's the name of the feature, right? So you have transfer order, and then in that you have the mapper, the data, the DTO, you have the repository shard, and so on and so on. So another step in this separation of concerns. But as you can probably easily imagine, there is a slight disadvantage, and it looks like this. So for a singular feature called once again transfer order import, you easily have already 6 files. And the feature itself is really just getting that one little transfer order and just translating it into domain model. That's it. You don't do anything else. So it gets overwhelming quite quick, for sure. So yeah, vertical slices, hooray, but you need to think about it. That's for sure. And the worst part of it is there's lots and lots of ceremonial code, because as you can imagine, those 6 files were kind of empty sometimes, because this is the example of the staging configuration, and staging in here is pretty much the same as backup. So just so you know, so if you want to stage the message, you have to have the staging configuration for this particular feature, right? And it's kind of empty, right? There's nothing in here. The only thing that actually makes sense is on line 13, which is the name of the container of the blob storage, right? That's the whole thing. All right. So initial shape for each feature was sort of like this. You have the DTO, mapper, command and handler, blob staging, dispatch endpoint, and dependency injection relevant registrations, not only in the constructor, but also in the iService collection, since it's all separated. You have a lot of that ceremonial code. It's a great separation, but you need good memory. Because not only do you have to create all those files, you have to remember about them. So simple example is that staging step, right? If you don't remember about it, there's nothing telling you that you forgot about from code review, right? But there's nothing automatic to tell you that you just forgot, okay? So I ended up looking like this. One eye always on the old feature that I already implemented, and one eye on the new feature that I was writing currently. So yeah, we wanted to improve that. Let's say the list. That's the whole idea. So we wanted to improve that, and our solution was really a generic package journey. What do I mean? How does it look? We understood that we have quite a few of those steps that we want to, well, generalize, right? We want to be able to repeat them every time. So this is those steps. There's staging, there's the receive step, the map step, the check. Oh, excuse me. Getting the check-in tags, dispatching, or getting the custom results, those are all separate steps that you need to do in this approach, because yeah, this is what we do all the time. And keen observers of you probably already realized we're using the T input, T output, which is the generic approach. So let me demo that. Let me show you how it actually looks like right now after the generalization, and why is it important in the first place. Okay, so what you need to do right now, if you have a new feature, you create a file with the feature name and the journey of that feature. This is what we used, right? Once again, package journey. So the only step you need to really remember about is to inherit from the package journey. And once you do that, you see right away that package journey requires you to give some types that will describe the feature itself, and it will describe the details of the feature and the details of that journey itself. So you have to give those types in, and those types are actually quite specific. So for example, the mapper needs to implement the our IMapper interface and so on, right? So those are very specific types that you need to give. And once you give it, you do have this error appear, and the error says that the base class of the package journey does not contain parameterless constructor. You can also see that my rider is hinting that I can do something about it, and what I can do is implement the missing members. So I do that right away. And here we go. I get two things for free completely in here, right? So first thing, I get the constructor and all of the dependency injection things that are generic, I get that for free. So you can see in here, there's the journey configuration, there's the mapper, and all of those beautiful things. And I also have to implement the dispatch step. And this is actually something that we actively decided upon because we realized quickly that since our systems communicate in all the different manners, we really need to have specific dispatching or specific communication to the systems to whatever we want to do next for our feature. All right. We'll implement that in a second, but do bear in mind once again, you have to specify all those types and you cannot forget about them because it will result in an error. You have to simply do it. That's it. And once again, constructor you get for free. You have a lot of those implementation details here for free. Dispatching, let's implement dispatching. And since we're using the example of very first connector in the system, our dispatch will actually just contact our integration API. So what we do is we prepare a request, and that request is a domain-specific request. Then we send it over through our transfer order status endpoint client, and we react on the response. That's it. Simple, right? And you probably already realized there's two new things in here, which are private, the endpoint client, and also the handler result factory. So the result factory is simple because we actually use it in different places in our solution. So we need to remember to add it into our constructor. However, the endpoint client is something completely new that actually utilizes the HTTP client underneath, right? But since it's completely new, we need to register it in the dependency injection container first. And we do it like this. We create the static method called register all services, and we trigger the register base services, which I'll show you in a second, but we also add the singleton for the endpoint client. And if you're screaming at your screen because the singleton HTTP client may be not a good idea, it actually utilizes the HTTP client factory underneath, so we're good there. Singleton is perfectly fine and actually recommended. All right, so the base services or the registration of the base services looks like this. Once again, this is the whole generic approach, so you don't have to worry about those things in general. You just have that automatically. All right, perfect. So what's the next step? Well, nothing. Let's just summarize how does it work and how does it look like right now after we implemented this whole package journey for each and every feature. So what you have to do is you create the package journey or you create that new class, right? That new class that inherits from the package journey. And then the next step is you let it guide you to create everything you need. Because after filling in all those classes, you are being guided through the rest of it, right? So you still have the DTO mapper command and dispatch endpoint. They are just, you don't have to remember about them. And this is especially important, well, when we cover the advantages. So, first thing, and the biggest one for me personally, is no memory required because you since you give those types, you cannot forget about the step, because one of the steps was actually the configuration of the journey, and that configuration also contains the name of the blob storage for the staging step. So even if you forgot, once you create that file, you have to fill that info in. There's no way around it. So when you have to fill that in, you are just like, oh yeah, actually there's a staging step in here. So there's no way to forget about it. And that's awesome, right? There's also a little bit less code just because we've got some of those generalized things, but it's not a huge difference. It really wasn't the target. So it's just like a bonus on top. That's it. Another advantage is actually a happy little accident, as Bob Ross would say, because we got mappers with custom interface, right? And it's not a huge thing on its own, but it looks like this, right? When you have the journey base and you have the mapper, that mapper needs to implement the IMapper interface, which also specifies the input class and output class. And it can be important for our particular thing just because we right away have the next step in improving this whole solution, improving this package journey approach. Okay, so what's the thing here? When you have the integrations team, and from time to time, there are people from the system A, from system B, sorry, that will approach you and they will ask questions about, okay, so I get the date of receiving the item. Like, where is that coming from? And you'll have those questions all the time, usually. So there's two possibilities. Either you write a good documentation, a good document that will explain it, and you once again remember about updating it each time you change something, or you do that documentation automatically. And this is our next step. This is our next idea. Since we're utilizing that one IMapper interface, we can actually, by reflection, gather all of the mappers, try to instantiate them, then gather all of the inputs, instantiate them, fill them in with random data, and push them through our mappers, right? And in the end, you've got all of the inputs, all of the outputs. You can try to match what was mapped from what. And that thing is a step away from creating an automatic documentation. Even if we cover 80, 90% of the whole thing, maybe not 100%, it's still better than writing this documentation manually. So yeah, that's definitely a next step for us for sure. All right. So yeah, to summarize this, the internal framework, when you cover all of the generic details and all of your domain, can really be not only easy to work with, but an actual pleasure. So really loved that thing. But we also improved it with just generalization. And it's surprising how much that can be of a benefit. So whenever you have the issue in the team, and our issue was we had really bad memories, you can improve that with code. You can improve the developer experience if you think about it, if you think how you want to do that. And that's what I want to encourage you guys to do. All right. That's everything. Thank you very much for listening to me. And if there are any questions, feel free to just um, to pop them up in the chat. And I think I will, as far as I understand, I will receive them right now on the screen. And I also wanted to remind everybody that the recording will be available in Facebook, but also on YouTube. All right, so the first question is, let me read it in Polish and then I will translate it quickly. Czy BLOBA jest dostosowany do konkretnego języka programowania lub może być używany w różnych środowiskach? So the question really covers is that BLOBA connected to a very specific language, programming language, right? Or can it be used in multiple solutions? Yeah, absolutely. It can be very generic, and the BLOBA term in very general thing really describes like all of the projects that are kind of boring and that needs to get the job done. The solution itself that I'm talking about, the solution that I'm describing here for the EPOS was really focused on .NET, obviously, because we had all of those parts that integrate with .NET and Azure. However, yeah, it can be generalized even more for sure. So yeah, I hope that answers the question. Okay. All right. Another question would be, does BLOBA influence the structure of the project, or is it a little bit more elastic with integrating with the code that we already have, right? So let me think about it for a second. Yeah. So the API framework is very generic. As you hopefully heard from me, so this whole idea of separating the integration hub or the integration API and the connectors, and the whole approach to giving you the basic tools like batching service, this is very, very, very generic. However, once again, this is the internal framework, right? So the internal framework is not something that I can give to anybody, right? This is something that is very specific for the company. And unless the company would like to make it open source, it's not really possible to transfer it to another project. However, if you have that in your company, you can use it for multiple projects. And this is exactly what we did, right? We had multiple projects, multiple different systems to integrate, and we used it in a few places. That's it. Oh yeah, it was. Oh, to complete that answer, it was also the very base of the whole project. So it was kind of the starting point for the project itself. So in this regard, this is definitely something. This is not something that you integrate into the project. This is something that you start working with, right? Okay, cool. All right, that's all the questions. That is lovely. Thank you very much once again, guys, for listening. If you happen to have any further questions, hit me up on LinkedIn. And that's about it for me today. So thank you once again. Have a lovely day and bye.